as we look at the second, third, and fourth examples for 1.6, graphing with transformations of functions. The second example has us going back to a little bit of Algebra 1 when we were graphing absolute value equations. So if we start to just sketch out that original absolute value equation, might have to go down on the keyboard to get the absolute value set up. Of course, this is equal to the absolute value of x. So this should look familiar. If I taught you in Algebra 2, we were talking about some pool shots that this kind of looks similar to. This is kind of an odd one that doesn't really make an appearance too much in Algebra 2, but here we are again with it. So just some basics on this. We see that the domain is continuing to the left and to the right. So we can say that the domain is going to be all real numbers, whereas the range kind of pinpoints down here at 0, but it continues up, so we can assume it goes to infinity. The function that they have us graphing here is equal to negative absolute value of x, where nothing's modified in there, but then we're deducting 4. So you may just want to think, what's going to change about this based off of the information that was given as far as the types of transformations? What's going to be different about this one? I think there are going to be two things that are different. Well, for one, if we're bouncing off of the idea of that high VO, if we look inside for any horizontal shifting, we don't see anything there, so we can assume that there's no horizontal shift. So this part's done. Whereas for the vertical shift, hopefully we can see that there's that -4 on the outside. So this is a -4, so we should be able to say pretty confidently that this is shifting down 4 units. And we can just give this a test run before we go to the original negative version of the equation. So as we see here, this definitely matched what we were saying. There's no horizontal shift, but this did shift down 4 units. So far so good. Keeping in mind that this original equation was negative, so what do you think this negative opposite version is going to do? How's that going to change the graph up? Well, if we look at the reflection portion, we see that this is a negative number. So since the A term is -1, we can assume it's going for a summation here. We can say, how about that? That works better. We can say that the graph is mirrored or reflected over the x-axis. And this is all because that first term is negative. This switches everything and flips it upside down. So let's see how that looks. Exactly what we were mentioning. The vertical shift of 4 is still there. It's still flipping over the x-axis, so going in a different manner. Some basics on this. The domain does not change, so this is still all real. The range, however, what do we think about the range? How's that going to switch up? I'll give you a moment to think that out. So hopefully you were saying that the range looks as if it's going to a point. It's similar to a mountain, whereas the original parent function's like a V. It's kind of as if you're working down from the mountain, whereas with this new equation, you're working up to a certain point. So hopefully we can see that that point that we're working towards is 0, -4. So we can say that the range starts way down. That's fine. So we can say -infinity, but it's eventually coming to a close as we round this out and end up at -4. That's the highest point. And it can include that, so we want to make sure we use brackets.